Okay. Alright, so fifth period, you should have picked up the answers to the review from yesterday from the table. It's the even and the odd numbers. The only part that's not on the review is number 42 through 46, and then the rational handout that you're picking up today. So if we go through number 42, it says, what do we know about negative numbers when they are raised to an odd power, and what about when they are raised to an even power? So if we had a negative number, such as -3 to an odd number, to the third power, then we know that's basically saying -3 times -3 times -3, so we know our answer is going to be a negative. And if we raise -3 to an even power, then we know that's -3 times -3. Two negatives are going to make our answer a positive. On number 43, it says evaluate the following expression. Pretty much you're just taking each one of these variables and plugging them into the problem. So we have A times D, so that's 3 times -2, divided by C to the A power. So we plug in C, you should have had 2 to the third power minus -3 to the second power. Some of y'all might have messed up on the denominator because you might have just did minus -3 and turned it to a positive, but you can't do that because the base is actually B to the C, so you have to do B to the C first, and then you subtract. So if we do the top 3 times -2 is going to give us -6. On the bottom, we have 2 to the third power, which you should have got 8 minus, because it's not going to turn into a plus. And then the -3 squared is going to give us 9. So that simplifies to -6 over -1, and then your final answer should have been 6. Everybody got that? Number 44, this is probably one that gave you problems. So let's look at number 44. That actually, everything is inside of the parentheses on that problem. And the exponent on the outside gets distributed to everything in the parentheses. So, if you distribute, you get 3 to the -2, t to the -2, divided by 5 to the -2, and r to the -2. And then we multiply it by 2 squared, t squared, over 4 squared, and r squared. So you distribute that -2 to the everything in the parentheses, and then 2 to everything in the parentheses. Was it important? Who was it?
I told him you were recording and he said never mind.
Who was it?
Okay.
Okay. So then, after this, what we basically do is take those negative exponents. Some of you might have put them in a calculator, and then your calculator would have pretty much gave you like a fraction over a fraction, something like that. What's 5 squared? 25? And so that fraction over fraction can confuse you. So here's the easiest thing to do this problem. And if you messed up, then just pause it or go back and figure it. Take those negative, those bases with those negative exponents, well, pretty much the whole problem, and just flip it. So move all that to the top so it's positive, move all that to the bottom so it's positive. So then 5 squared, r squared goes to the top and becomes positive. And 3 squared, t squared goes to the top and becomes positive. And so all that stays the same. So we simplify this, you should have got 25 r squared divided by 9 t squared, and over here you got 4 t squared divided by 16 r squared. And then from here you just multiply both fractions together. Remember when multiplying fractions, you multiply numerator times numerator. So 24 times 4, those two coefficients turn into 100 r squared t squared. And on the bottom, 9 times 16 turns into, I don't know, my mind was blank. 54, 34, 144. R squared, T squared. And then, give me a calculator. So we reduce 144, 100 divided by 144. And I write the answer up here. We get 25 over 36. Our r squared and our t squareds basically cancel out because when you subtract, anything to the 0 is 1, so your answer should have been 25 over 36. If you don't understand, just pause the video, try to absorb it, or ask a partner for help. If not, then move on. 45. So here we have 2 points that lie on the same line, and it wants us to find slope. So here we do our exponent rules as well as bringing slope into the problem. If you remember back with slope, it equals y2 minus y1 divided by x2 minus x1. And so we label our x1, y1, x2, y2, and we just plug it in. So we end up with the slope is equal to 3RT minus 6RT over 4ST minus 8ST. And the good thing about this is they're like terms, so they just combine. We have 3RTs minus 6RTs, then that means we have a total of negative 3RTs. Remember with subtraction, the exponent rules do not apply, nothing's changing. All we're doing is just combining like terms. At the bottom, 4STs minus 8STs gives us a negative 4STs. So the first step is just to combine those like terms using addition and subtraction. Now our division rules come in, because now we're going to divide and we have some exponents. On the exponents, basically this is t to the 1 minus t to the 1, it's going to be t to the 0, so those cancel. And we know 2 negatives make a positive, so the final answer is 3r over 4s. Everybody got it? And then the last one is talking about the speed of light and the distance from the sun, and it wants us to find the seconds it takes to get to Mars. So write an answer in scientific notation. We know that speed equals distance divided by time, right? And so in this case, we're looking for time. So basically, you multiply both sides by t and divide by s. So our equation that we're using is time equals distance over speed. So we divide these two, which if I write that in scientific notation, I end up with, oh, this problem doesn't work out. The answer isn't going to be politically correct or really correct because it's scientific, but we still work it out. Because this one's going to be 2.3 times 10 to the, is it 12? 11. 10 to 11 divided by 3 times 10 to the 6. If we divide 2.3 divided by 3, our coefficients, we end up with 0.666, which repeats, and we know that we don't really leave it in that form. We can't leave it in that form, so how do we go in this calculator and change them to a fraction? I can't remember.
Oh, menu 2. Menu 2. Change it up.
Oh, yeah. Okay. Oh, duh, I could have did something wrong. So we get 23 over 30, basically. And then on our rules, we subtract exponents and we end up 10 to the 5th power. So that's the answer you probably got, or some of y'all might have did 7.6 repeating, which I would not do that with a repeating decimal. But the reason I say it's not supposed to be correct is because you can't have a number that's less than 1 as scientific notation. But in this case, it does show up, so that should have been your approximate answer. All right, if I can get everybody to focus up here. Now we're going to move into today's, which is practicing rationals. Here, I want y'all to pause the video, do the practice on your own, unless y'all already did it, and then watch how to do the answers. So if we remember with rationals, we have 27 to the 1/3. Remember, if you write that as a radical, how to write that as a radical, guys?
3.
The 3 is on the outside and 27 is on the inside. And then we break down the 27 and we get 9 times 3 and then 3 times 3 times 3. And we're going to circle our answer in sets of what? 3s. Because it has a 3 to the third, the nth term is 3. And so our answer is just 3. Take one number from the pair. Everybody got it? Number 2, 256 to the 5 over 4. Remember, 256 goes under the radical. And what's going to be outside?
4.
The denominator, which is 4. And then this is saying 256 to the 5th power. Now, we know that number is going to be tremendously large. So I would do this part first and then raise it to the 5th power. Because if you do 256 to the 5th, I'm sure it's probably going to get an answer scientific because it's too large for the calculator. So we break down 256, and how can we break down 256? What?
16.
128.
times 4.
You haven't done this yet?
16.
64 times 4. And then we break down 64 to 8 and 8 and 4. And then, oh, not 4. 2 and 2. And then that breaks into 2 and 4. And 2 and 4. And then our 2 2's come down. And then that breaks into 2 times 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 2. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. Yep. And then since our 4 is on the outside, that means we circle in sets of what?
4.
4. So we have 1 set. I circled too much. 1 set, 2 set, right? 2 sets of 4. So that means our answer is going to be 2 times 2, which is what? 4. So does that mean we stop at 4?
No, we got
No, because we still have to go and raise it to the what? 5th power. And so what you get for your answer? 1004? Oh, sorry. 1024. Any questions on that one? Okay, number 3. We have 2 to the 3x plus 12 and 1 equals 128. Now remember, with a problem like this, we have to try and make both of them have the same what? Base. So how can we make 128 have a base of 2?
Divide by 9.
Y'all broke it all the way down?
Yeah.
And what did you end up with? 2 to the power 7. So you put that in the calculator, 2 to the power 7 is equal to 128. If you hadn't done it yet, you're just pretty much breaking it all the way down until you see how many 2's you can get. So 2 to the power 7 is equal to 2 to the 3x plus 10. And now that our bases are the same, what does that mean about our exponents?
They have to be the same.
They're equal. So then we can set 3x plus 10 equals 7. Subtract 10 on both sides. 3x is equal to negative 3. Divide by 3, and your answer should have been x is equal to...
Negative 1.
Oh, my bad. Not paying attention. Negative 1. Everybody got that? 3 divided by negative 3 is negative 1. Any questions on that? Okay, number 4. We have 8 to the x is equal to 16. Is there any way we can make 16 have a base of 8? No, because 8 to the 1 is 8. 8 to the 2 is going to be 64, right? So what can we do to both of those numbers? Reduce both of them. If it doesn't work for what it is, we can reduce both of them. And we can break that into 2 times 4, which is going to be 2 times 2 times 2. And so that's basically 2 cubed, right? But it also has what already on there? An x. So 2 to the 3 times x. Does everybody see what happened? So 8 can break into 2 to the 3rd power, but we also had an x out there, so it's basically 2 to the 3 times x. And then we can break 16 down to 8 and 2, 2, 4, 2, and then 2, 2, 2, 2. And so that's going to be 2 to the power of what? 4. And so now we made them have the same basis. So same base means that the exponents are equal. We divide both sides by 3, and so x equals 4/3. Any questions on this one? Everybody got it? And then lastly, we are oh no, we have 2 more. Simplifying 288, and how can we break down 288? 12 times 24. Then we can break, I'm going to do something different. You can keep going down to prime numbers if you want to, but how can we make this easy? Watch you move it, Cody.
I didn't.
Why you did move it.
I did?
It's swinging, yes, you moved the thing.
No, he pushed his backpack back.
Oh,
Oops.
y'all be still. We could break 24 down to what?
12 times 2.
12 times 2. And bring this 12 down. And could we stop here?
Yes.
Yes.
Because we have a pair of what? 12. If you want to break it all the way down, you can. So basically 12 comes outside, and what's left over? 2. So the answer is D. Or some of y'all probably all the way down, 3s and 2s. But you could have stopped there. You got to be able to look at it until what's E. Lastly, we have 20, which breaks down to 4 and 5. 2 times 2 times 5. And then we have 3 x's and then 2 y's. So we have a pair of 2's, pair of x's, and a pair of y's. Remember, one number from each pair comes outside, so you end up with 2xy. And then what's left over? 5x. That's the last part of what we got in test. Make sure you study. The test is going to be tomorrow.